to look at calculating the derivative in various ways. In one of the last lessons, we talked about what a derivative is in calculus, and it's a function that measures the instantaneous rate of change of another function at a specific point. Essentially, it represents the slope of the tangent line to the graph of the function at that point. It tells you how fast the function is changing at any given moment. So we have some notations for the derivative. And the derivative of a function y equals f of x may be written in any one of the following ways. One way we can represent a derivative is by writing f with an apostrophe. That apostrophe is called prime. So you would read that as f prime of x. You also have this other notation, which is the derivative of y with respect to x. And then here we have the derivative with respect to x of the function f of x. Or you can just see a derivative written as capital D with the subscript x of f of x. So again, that's just the derivative of the function f of x with respect to x. Let's look at some rules for derivatives. The first rule is called the constant rule. And that basically just tells us that the derivative of a constant is always going to be 0. Okay, so more formally it would say if f of x equals some constant, let's call that constant k. Then, and k could represent any real number. Okay, then f prime of x is the derivative of x with respect to x, which is just 0. So the derivative of any constant is 0. Now, if you think about that, it makes sense, because if we have a constant, let's say the number 9, f of x equals 9. If you were to graph that, you get a horizontal line. And what is the slope of a horizontal line? The slope is 0, right? So, and again, when you think of slope, or when you think of derivatives, right, derivatives represent the slope of the tangent line. So the tangent line there to the graph at that point would just be 0. So f prime of x would be 0. The derivative of pi would be 0. And if y equals 2 to the third, then find the derivative of y with respect to x. Well, 2 to the third is 8, and y equals 8, again, is a horizontal line. It's a constant, so your derivative is 0. So all of those functions have a derivative of 0. Now, how do we figure out the derivatives for other types of functions when they're not constants? So what I'd like you to do is think about this table here, which gives you the function. It tells you n, which is the power, and it gives you the derivative. So the table to the right lists various functions in the form y equals x to the n, along with the corresponding degree and the function's derivative. Analyze the table and write a brief description of what you notice. Try looking for a pattern. So take a few minutes and try to do this. You can pause the video and then unpause when you're ready to go over it. So while you're looking at this table, one of the things you should have noticed was that if you have a function in the form of x to the n power, the derivative is found by multiplying the exponent by the constant, and then you're going to decrease the exponent by 1. So, for instance, if I was to multiply this power times that coefficient there, 0 times 1 gives me 0, right? So 0 times anything is just 0. So the derivative of a constant is just 0. Okay, so here we have f of x equals x. And the degree is 1. So I'm going to multiply 1 times the coefficient, which is just 1. And then I'm going to subtract 1 from the power. 1 minus 1 is 0. So you get 1 x to the 0, and x to the 0 is just 1, so 1 times 1 is 1. For f of x equals x squared, you've got 2 times 1, which is 2, and then take 1 away, you get 2x to the first. For 3, it's 3 times 1 is 3, and then 3 minus 1 is 2, so you get 3x squared. For 4, it's 4 times 1 is 4, take 1 away, you get x to the third. For negative 1 times 1 is negative 1, and then when you take 1 away, negative 1 minus 1 is negative 2. Remember that when you have a negative exponent, it's proper to place it on the bottom to make it positive, so it's just negative 1 over x squared. X to the 1/2 power, you have a rational exponent there, and the rational exponent is also a radical, so this is also equivalent to writing the square root of x. So the power is 1/2, and 1/2 times 1 is 1/2, and then when I take 1 away, a half minus 1 is negative a half. So here this would just be 1 over 2x to the 1/2, or you can also write it as 1 over 2 times the square root of x. Okay, so the derivative of f of x equals x to the n is found by multiplying by the exponent n and decreasing the exponent on x. So for example, f of x equals x squared. If I want to find the derivative, I'm going to multiply the exponent times that coefficient, which is just be 2, and then we're going to subtract 1. So it's just 2x. So that brings us to what's called the power rule, which is a very important rule in calculus when you're finding derivatives. And the power rule just says if f of x equals x to the n for any real number n, then f prime of x is just equal to n times x to the n minus 1. Let's take a look at some examples. So here we want to find the derivative with respect to x of x to the 6th. So I notice this is in the form of x to the n power. So what I need to do is take the 6 and multiply it by the 1, the coefficient, right? So you have 6 times the 1 that's there, which would just be 6. And then it's to the x, it's times x to the 6 minus 1 power. So your final answer is just 6x to the 5th power. In letter B, if f of t equals t, then find f prime of t. So again, the power of t is 1. So I'm just going to do 1 times 1, which is 1. And then I'm going to subtract 1. So that gives me t to the 0, and any non-zero number raised to the 0 power is 1. For letter C, if y equals 1 over x to the third, find the derivative of y with respect to x. So 1 over x to the third, I can rewrite that as x to the negative third. So now it's in the form of x to the n. So I'm going to multiply my exponent times 1, or whatever coefficient is there with the x. So that would just be negative 3 times 1, which is negative 3. And then I'm going to subtract 1. So you end up with negative 3x to the negative fourth, but we wouldn't leave it like that. We would keep the negative 3 where it's at, and we would move the x to the fourth in the denominator to make that exponent positive. For D, if y equals the square root of z, find the derivative of y with respect to z. So remember, the square root of z can be written as z to the 1/2 power. So now it's in the form of x to the n, or z to the n, if you will. So it's just going to be 1/2 z to the 1/2 minus 1 power. Well, 1/2 minus 1 is negative 1/2. So what I have is 1 over 2 z to the 1/2. And then I'm just going to rewrite that back again as a square root. So it's 1 over 2 times the square root of z. For letter E, it says if f of x equals the 7th root of x to the 5th, find f prime of x. So I'm finding the derivative of y with respect to x. So another way to write the 7th root of x to the 5th is x to the 5/7 power. Now it's in the form of x to the n. So now I'm going to multiply 5/7 times 1. So that gives me my 5/7. And then it's times x to the 5/7 minus 1. Well, 1 can be written as 7/7. So now I have 5 minus 7, which is negative 2/7. And we know we can't leave our answer like that because we have a negative exponent. So the 5 and the 7 stay where they're at, but we're going to slide the x down in the denominator to make it positive. So it's 5 over 7 times x to the 2/7 power, which if you want, you can rewrite that as 7 times the 7th root of x squared. I'd like you to pause the video and try the next one on your own, and then you can unpause when you're ready to move on to the next rule. So the next rule we're going to look at is what's called constant times a function. Okay, so far our constant has been a 1, right? Like we have a 1 here. So really all we're doing is adding on to the power rule, and we're just saying if this number was something other than a 1, you're still going to multiply this power times that coefficient and then subtract 1 from your exponent. So if, we'll call it g prime of x, exists, then the derivative of f of x equals k is just a constant, right, times g of x is f prime of x, which is just the derivative with respect to x of k times g of x, which is just going to be k times g prime of x. So what we're doing is we're finding the derivative like we just did, and then we're multiplying it by the constant. So let me show you what that means, and then I'll show you a quick way to do it. So if we use the constant times a function rule, what we're saying here is to take the constant, which is 8, and we're going to multiply it by the derivative of x to the fourth. So we just learned in the last little piece that the derivative of x to the fourth would be 4x to the third. So all we're doing is multiplying 8 times 4x to the third, which gives us 32x to the third. So instead of doing that separately, you can just do it all in one giant step, right? We're just going to multiply 4 times 8, which gives us the 32, and then decrease your exponent by 1. So that's essentially what the constant times a function rule tells us. Okay, we can try that with b as well. So we can multiply 12 times negative 3/4. Okay, so to multiply fractions, we just go straight across. You get negative 36 divided by 4, which is negative 9. And then it would be x to the 12 minus 1, or 11th power. In letter C, we're finding the derivative of t. So we've got negative 8t, and again, your exponent is 1. 1 times negative 8 is just negative 8. And if I subtract 1 from that power, I get t to the 0. And we know that t to the 0 is 1, so negative 8 times 1 just gives us negative 8. In letter D, if y equals 6 over x, find the derivative of y with respect to x. So I'm going to rewrite that as 6 to the negative first power. And then I'm going to multiply negative 1 times 6, and then subtract 1 from my exponent. And we would just rewrite this as negative 6 over x squared. Okay, I'd like you to pause the video and try the next two on your own, and then you can unpause when you're ready to move on. Let's next look at what's called the sum or difference rule. So the sum or difference rule tells us that if f of x is equal to u of x plus or minus another function we'll call v of x, and u prime of x and v prime of x exist, then f prime of x is just going to equal the derivative with respect to x of u of x plus or minus v of x. So we would just take the derivative of u, which would be u prime of x, and then add or subtract it with the derivative of v, which is v prime of x. Okay, let's look at an example to make it more clear. So here we have two, think of it as two separate pieces that make up this function, right? Here's u of x, here's v of x, and I'm adding. So what we're going to do is we're going to take the derivative of each and combine them, because that's all the rule tells us to do. So pretend u of x is just 6x cubed, and we'll pretend v of x is 15x squared. So if I want to find the derivative of u, we know that's just going to be 18x squared. And the derivative of v is just going to be 30x. So my final answer is just u prime of x plus v prime of x would just be 18x squared plus 30x. In letter B, you've got p of t equals 12t to the fourth minus 6 square root of t plus 5 over t. So to find p prime of t, the first thing I want to do is rewrite this. So 6 times the square root of t, we know we can write that as 6 times t to the 1/2 power. And then 5 over t we can write as 5t to the negative first. Okay, and then I'm just going to apply my constant rule and power rule. So I've got 4 times 12, which is 48, and then subtract 1 from the exponent, you get t cubed. Then I've got a half times negative 6, which is negative 3, t to the negative 1/2 power, and then negative 1 times 5 is negative 5, t to the negative second power. And then I'm going to go through and rewrite this the proper way. So I would have 48t cubed, and then minus 3 over t to the 1/2, which you can write as the square root of t, and then minus 5 over t squared. For letter C, we've got f of x equals 4x plus 6 over the square root of x. Okay, so I'm going to rewrite this as 4x plus 6 times x to the 1/2, negative 1/2 power. Okay, because when I'm dividing by the square root of x, I'm dividing by x to the 1/2. So remember, if I want to move it to the top, I need to change the sign of the exponent. So now I'm going to multiply 4x times x to the negative 1/2. When I'm multiplying like bases, you add exponents. So 1 plus a negative 1/2 just gives me positive 1/2. And then plus 6x to the negative 1/2. And then I'm going to take the derivative. So 1/2 of 4 is 2. And then you're going to decrease the exponent by 1. So you get 2x to the negative 1/2. And then negative 1/2 times 6 is negative 3. X to the negative 1/2 minus 1 gives you negative 3/2. So we can rewrite this as 2 over the square root of x minus 3 over, so you've got the square root of x and then it would be to the third power. Well, you can actually take the square root of x to the third, right? Because it's made up of x times x squared. And you can take the square root of x squared, it's just x. So we can rewrite this as 2 over the square root of x minus 3 over x square root of x. For letter D, so here we have a binomial, we're squaring it, right? And we're not quite at the rule yet where we can simplify this easily. We're going to learn about a rule called the chain rule in later lessons that will allow us to simplify something like this and find the derivative. But at this point, what you might want to do is expand the binomial. So, think of it as like 4x squared minus 3x times 4x squared minus 3x. And of course, if you were to expand that, you would get 16x to the 4th minus 24x cubed plus 9x squared. And then it's just a simple constant times power function rule. So 4 times 16 is 64, and then it would be x to the third. 24 times 7, that's going to give me 72, and then x squared, and then plus 18x. Try the next one on your own, and then you can unpause the video when you're ready to move on. Okay, in this next example, we're going to let f of x equal the function 4x cubed minus 9x squared minus 30x plus 6. And we're asked to find the equation of the tangent line to the graph of f of x when x equals 2. So first of all, I need to figure out what point that would be, right? So to do that, they're giving me an x value. I'm just going to plug in the 2. So I'm going to have 4 times 2 cubed minus 9 times 2 squared minus 30 times 2 plus 6. And I've shown everyone in enough videos, that you can use your calculator to come up with that solution. You can use the table if you want. But when you do that, you should get negative 58. So that tells me that I'm looking at the point 2, negative 58, right? We want the equation of the tangent line to f at that point, okay? So the first thing we would want to do is we want to find the slope, right? Because the derivative and the slope are related. So the first thing we're going to do is find the slope. And to do that, we're going to find the derivative. So the derivative of your original function is just going to be 12x squared minus 18x minus 30. And then remember, the derivative of a constant, in this case 6, would just be 0. So I'm going to find f prime of 2. So again, I'm just going to substitute 2 into this new expression, and you end up with negative 18. So that is the slope of the tangent line at this point, okay? So how do we find the equation of the tangent line now? We just found the slope. Well, I can use my point slope formula. So I've got y minus, my y1 is just negative 58, so that's going to turn into y plus 58. My slope I just found is negative 18, and then I've got x minus 2. And then I'm just going to clean this up, so I've got y plus 58 equals negative 18x plus 36, and then I'm going to subtract 58 from both sides, and you would get y equals negative 18x minus 22. So that's the equation of the tangent line to that function at the point 2, negative 58. Okay, and we can graph that function here and kind of take a look and see what's going on. So I've got y equals 4x cubed, and then it's minus 9x squared minus 30x plus 6. Okay, so here's my function, right? Now I'm going to plot this. Y equals negative 18x minus 22. And let's also graph the point 2 comma negative 58. Okay, label that. So we're going to be down here. Okay, so you can see that green line there passing through the point 2, negative 58 that's sitting on that function, and the slope of that line, y equals negative 18x minus 22, is actually negative 18, right? Which we found to be the value we got when we used the derivative. Okay. The next problem says find all values of x where the tangent line is horizontal. So we kind of talked about this in the beginning of the lesson. The tangent line is horizontal means that the slope equals 0. And if the slope equals 0, that tells me that f prime of x also equals 0. So what I'm going to do is I'm going to take my derivative, 12x squared minus 18x minus 30, and set it equal to 0, and find all the values of x where y would equal 0. So of course you can see you can factor here, and I can factor a 6 out of there, so I'm left with 2x squared minus 3x minus 5. And then that's just going to factor into 2x minus 5 times x plus 1. And then I'm going to use the zero product property. I'm going to set each of those factors equal to 0. So I would get 2x minus 5 equals 0. So I know x is 5 halves. And x plus 1 equals 0, so x equals negative 1. So that tells me the tangent line is horizontal when x equals 5 halves and x equals negative 1. At those 2 points, the tangent line would be horizontal. One application of all of this is marginal analysis. We kind of looked at the term marginal in previous lessons, right? And when we talked about marginal, we were looking at the slope. So marginal analysis are concepts that include something called marginal cost, which we looked at before, marginal revenue, and of course, marginal profit. So we looked at all of that, right? I mean, we looked at cost functions, we looked at revenue, we looked at profit. So marginal is slope, and we know slope is just rate of change. Okay, an example is like marginal cost refers to the rate of change of cost. And the marginal cost is just found by taking the derivative of the cost function. Let's look at an example. Suppose that the total cost to produce X barrels of a beverage is given by C of X equals 0.4x squared plus 10x plus 50. First, we need to find and interpret the marginal cost for 60 barrels. So marginal, again, refers to rate of change or slope. That tells me I need to find the derivative. So I need to find C prime of X, which we know we're just going to use our power rule. So we've got 2 times 0.4, which is 0.8, and then I'm going to subtract 1 from the exponent, and then the derivative of 10x is just 10, right? Because it's 1 times 10, and then x to the 0, which is 1, so 10 times 1 is just 10. So what this tells me is when x equals 60, C prime of 60 is going to be 0.80 times 60 plus 10. So that's just going to give me 58. So therefore, after 60 barrels of the beverage have been produced, the cost to produce one more barrel will be approximately $58. Okay, because remember, slope is change in y over change in x. Y is cost, x is barrels. So after 60 barrels have already been produced, if you want to produce one additional barrel, it's going to cost approximately $58 more. Now we want to find the actual cost to produce the 61st barrel. Okay, so what we need to do now is find the difference between the 61st and the 60th. So all we need to do is take our function and we're going to plug in those values and subtract. So we've got 0.4 times 61 squared plus 10 times 61 plus 50, and then minus 0.4 times 60 squared plus 10 times 60 plus 50. And this first piece here gives you 2,148.4. And then the second piece gives you 2,090. And we get 58.4, which is really $58.40, right? So notice that the marginal cost, which we got earlier, which was $58, is close to the actual cost, right? So the actual cost here is going to be $58.40. You can take a minute and try the next problem on your own, and then that will take us to the next lesson. So I'll see you guys shortly. I hope you enjoyed this lesson. If you have any questions, please.